Most people have heard of MRI, which is magnetic resonance imaging. It's the best scanning technology for getting high-resolution anatomical pictures of any part of your body, and it's especially useful for the brain. But most people haven't heard of MEG, which is magnetoencephalography. MEG measures brain activity, millisecond by millisecond, but it doesn't take pictures of the brain like MRI does. In several studies I've done, I've scanned people with both technologies, so I can combine them in my analyses and get that structural detail that comes from MRI, while also getting the functional information that comes from MEG. This allows you to make movies of the working brain while someone performs different tasks, and you can see the patterns of activity with temporal precision. This is just such a movie of brain activity recorded while a person was hearing words and then thinking of their meanings. The 0 time mark is the exact moment when a word was presented auditorily. You can see the first regions to be fully engaged are in the temporal lobe along the side, which is where sound first hits the cortex after bouncing through the thalamus. Then you see the pattern of activity move forward from there to the frontal cortex, as the person is then thinking about the meaning of the word they just heard. This is a similar task, but this time the person is seeing the words before thinking about their meanings instead of hearing them. For this task, you see a somewhat different pattern of cortical activity. This time, the first cortical regions to be engaged are in the occipital lobe in the back, where visual information gets relayed from the thalamus. Then, the pattern of activity moves forward from there to frontal cortex again, as the person is thinking about the meaning of the word they just read. With this rare, detailed combination of information about both the timing and the location of brain activity, this multimodal imaging technique becomes a really powerful tool for studying human brain function. With even just these 2 movies, you can see important principles about human functional brain organization. You can see the different cortical input pathways for the visual and auditory sensory modalities, and you can see the front-to-back separation of sensory perceptual processing versus the more truly cognitive processing. If anyone wants to read source publications, I've cited some in the description.